Okay, the second video, we'll look at some more examples. So here in example 3, I have 4 different sequences defined by their nth term. And I want to know, do the sequences of terms converge or diverge? And so that for the first one, I'm looking at 2n minus 7, 5n plus 3. And I'm really looking at the fact that the power of the numerator and the denominator are the same. So what I'm going to do is take a look at the limit, right? So the limit as n goes to infinity of just a sub n in general. And because of that ratio of 2n, 5n, I know that the terms themselves will approach 2/5. Since the limit of the terms of the sequence converges, I know that since I know that the limit exists, then I know that the sequence converges. So the sequence of terms converges. And again, that's the sequence of terms. Okay, so then we look at part B. Now, part B looks like it's alternating, but if you start looking at the different terms here, when n is an odd value, you get -1 plus 2, so you would get a 1. And then when n's an even number, you would get +1 plus 2, which is 3. So although this is alternating between 1 and 3, it's not an alternating sequence in terms of positive, negative, positive, negative. But at the same time, the fact that it's alternating between 1 and 3, the limit itself does not exist. Like if you try to say, what is the limit as n goes to infinity of the sequence of terms, a sub n, it diverges, right? It doesn't exist, right? Because it's not getting any closer to 1 than it is to 3. So we would say the sequence of terms diverges. Okay, second one. So again, thinking about the limit as n goes to infinity of the sequence of terms, and I'm noticing that the numerator is greater than the denominator. The terms are getting bigger and bigger and bigger and bigger. So the limit as n goes to infinity actually equals infinity, and therefore the terms themselves diverge. So the sequence of terms diverges. And I'm saying the word sequence of terms to emphasize, because we're just looking about just what's happening with the sequence, not the summation, the sequence. Okay, and then this one, same thing, limit as n goes to infinity of a sub n as a sequence of terms. And I don't know if I stress this, this bracket notation that means the sequence of terms. And so if you want to look at that as a positive exponent, you certainly could, like 1 over e to the n, then it's very clear that limit goes to 0. And since the limit goes to 0 of the, we know that it converges, and therefore the sequence of terms converges. Okay, so again, as long as the limit exists, as long as the limit it has a finite value, then we know the terms converge. Okay, now let's shift gears slightly to talk about a series. Okay, a series is the summation of those values. So rather than just listing them out, we want to add them all up. And we've already dealt with a few series. One of the series we've dealt with is a geometric series. We've seen harmonic series, we've seen, series that are telescoping, that are defined by partial fractions. And so, and really the bulk of this chapter is going to focus on series. And, what kind of behavior can you, find out about that series? Is the series converging, diverging, alternating, things like that. So, and just again, a couple of definitions or things to think about. So a series, infinite series, right? No, we're going up to infinity, converges if its sequence of partial sums converge. And so a partial sum would be, so look at the first term, and then look at the sum of the first 2 terms, and then look at the sum of the first 3 terms, and then look at the sum of the first 4 terms, and then look at the sum of the first 5 terms, and look at the sum of the first 6 terms. And so you start looking at those partial sums. Does that series converge? And so one way to look at that and think about that. So let's look at partial sums. Just use that definition. So if you look at the sum of the first one term, or like, I guess, let S be 0, like what's the sum of just the 0th term? So when n is 0, we get 10 to the 0, which is 1, so 7 over 1. So the first sum is just the first term, so that's 7. Now, S sub 1, that's going to be 7 plus, and then we add 7/10, because when n was 1, right, we get the term 7/10. So that's 7.7. And then the second one would be 7.7, because that's that, plus the second term, so 7 over 100. Which actually is really nice, because now that's 7.77. And then, okay, so S sub 3. So that's the first 3 terms plus the next one. So 7.77 plus, if I let n be 3, so that's 7/1000. So now I got 7.777. And so then, hopefully you see that as I continue to add terms, you're just approaching 7.7 repeating. So I know that the partial sums are going to converge to 7.7. So therefore, I know overall, I could say that the series itself converges. And so the series, again, that means the summation of those values, right? It doesn't mean the terms themselves. It means the sum of them. And so I would say it converges because the limit as n goes to infinity of our partial sums is equal to 7.7 repeating. So since the partial sums converge, I know that the series will converge. And actually, it's a geometric series, so we should have been able to add that up anyway. Okay, let's look at another example of partial sums before we look at that a reminder of our geometric series. So suppose we don't know necessarily everything about our series. We just know it has an nth partial sum defined by this. And so we have to be really careful that this is not representing a sequence. It's actually representing the partial sum. So once I realize that that's the partial sum, does its limit exist? The limit as n goes to infinity of a sub n, well, that's going to equal 5 over 2, because they are the same, right? The same value in terms of they're both linear. They have the same power. So yes, since the sequence of partial sums converges, I know that the series converges. So yes, the series converges. So, and again, the series means the sum of the entire thing, even though I don't know what that is, but I'm basing it on the partial sums converging. Yes, series converges because the partial sums converge. And how do I know the partial sums converge? Because the expression that is that has been given to us, that expression has been given to us as what exactly the partial sums are. The previous example, number 4, we were able to actually calculate it, right? Okay, so and then in terms of like a geometric series, right? So a geometric series, just as a quick reminder, a geometric series will always converge if your ratio is less than 1. I should say its absolute value. It'll diverge if it's greater than or equal to 1. And you can actually sum it up, and this is what we did in honors pre-calc, by a over 1 minus r. Okay. So, that's that, like, I always talk about that, adding up half the remaining distance. Like I'm trying to leave the room and I'm going to go half the remaining distance. So like you take half that distance, and then half of the half is a fourth, and then half of the half is an eighth, right? Half and a half is a 16th. And so here is a geometric sequence that we can actually add up. And we know that because our ratio is less than 1. So one way to express that would be as n equals 0 to infinity of the first term, which is 1/2, times 1/2 to the n. So that's a way to represent all of those terms, and that's letting our lower index be 0. Certainly you could let your lower index be 1, and you could rearrange your your exponent up there. That's fine. It doesn't really have to just be this way, but this is what our textbook uses quite a bit. And so then, we just do a over 1 minus r. First term is 1/2. 1 minus, our ratio just happens to also be 1/2. So it's 1/2 over 1/2, which is 1. So again, the irony is that I know that distance is one whole thing, but I'm never going to run out of terms because there's always going to be a little bit of distance left over. Okay. And we just really saw that when we did like the Horn of Gabriel, right? Where we had a infinite length, but finite area, which was really cool. All right. So that's our second of 3 videos. I'm going to do one more simply because, again, I want to have a good basis, of these definitions and really the distinction between what does it mean to be a sequence of terms and analyzing, does the sequence itself converge, and then looking at it as a series. Now let's start looking at the sum if you start adding things up. And so far, all we've looked at is, do you know something about its partial sums, or do you know that it's a geometric series?